Namaskar, my dear friends. Let us continue the session for network theory. So, what we were discussing is DC networks. In that, we will be talking about fundamentals and basics of electric circuits. So, let us see first thing what we will talk about is what is the mechanism of electric energy flow in a conductor. Okay. So, how electric energy actually flow across the conductor is we can tell that as long as an independent source is connected in a network. Okay, so any circuit you take, if an independent source is connected, all the RLC element like resistor, inductor, capacitors, so they absorb energy from source. So the source which is connected, these RLC element will be absorbing energy from the source. In this in this what happens basically is the current always flows from positive terminal to negative terminal. Okay, because they are taking it from source, so you have to understand these RLC element will be taking energy from positive terminal to negative terminal. Okay, for example, capacitor is absorbing energy means what? It is storing energy and no energy is dissipated in the form of heat. So capacitor actually stores energy and it does not dissipate any energy. Okay, so that's the understanding you should have. Next is same thing is there for inductor as well. Okay, so it also absorbs energy and nothing is dissipated in the form of heat. However, this is not the case for resistor. We can say that however resistor is absorbing energy means everything is dissipated or it is wasted in the form of heat. Understood? So we can say one more thing, in the absence of source, okay, like we don't have the independent source which is connected across the network, the source energy of capacitor and inductor like L and C elements are delivered to the resistor. Okay, now while doing so, what we will talk about while doing so, the current through inductor and capacitor, okay, elements always flows from negative terminal to positive terminal. So we had talked about from the source it was positive terminal to negative terminal. However, when they are taking from L and C element, it will be from negative terminal to positive terminal. I'll show it to you how it is done. Okay. However, the current through resistor is still like in the first case also it was there from positive to negative, and in this case as well flows from positive terminal to negative terminal. Okay. So in that case what we can do is we can write down some terminology like this is, let us say we can write it down resistor. So resistor is nothing but memoryless element, like it doesn't have memoryless element, like it takes energy and it dissipates all of them, it does not give you back. Okay, whereas my inductors and capacitor, they are memory elements, like they stores energy and then they deliver it to you back. Okay, now you know already. Let us say we have a resistor element, let's say we have 2 ohm. Okay, so and a current that is flowing across this particular element, let us say 5 ampere. So what will be the voltage across this? So voltage across this will be current into resistance, that is I into R, that is 10 volt. Understood? So this is how it is calculated. So you know already, if you want to find out power, so power P is equal to I square into R, that can be written as also V square by R, and that can be written as V into I. Okay, so whatever way you want, you can calculate that. So can you tell me what will be the power in this case? So let us say I will put it V into I. So in that case 10 into 5, that is 50 watt. So 50 watt is the power which is going to be delivered to this particular resistor. So now I will tell that this particular resistor is absorbing energy 50 watt absorbing. Okay. Now can I tell it that this resistor is absorbing 50 watt of power? It means actually negative of 50 watt of delivering. It means what? I will tell that resistor is delivering minus 50 watt of power. Okay. It means it is absorbing plus 50 watt of power. It means it is giving minus 50 watts of power. So you can have this particular relation very handy with you, that positive energy is absorbing means negative energy is delivering, and positive energy is delivering means negative energy is absorbing, like that. Okay. So with this an assumption, we are going to talk about some theorem. Okay. So first of all, we'll talk about power convention. Power convention. And then we'll talk about Telegens theorem. Okay. So there are a lot of questions that is being asked in this particular power convention as well as Telegens theorem. So you have to understand very nicely like what it is exactly. Okay. So basically, let us say I am going to have an element here, and which is going to give me a current entering as I. Okay. And this is, let us say, my positive terminal, and this is negative terminal, and this is a voltage V. Okay. So what will be my power? That will be equal to V into I, and this will be my absorbing. A, I will write it for absorbing. So I'll put it A as absorbing and D as delivering. Okay. D as delivering. So in that case, I will write it down as, this is the positive terminal current is entering. It means I will tell power is equal to V into I absorbing. Similar to that, if I talk about one more element, which is, let us say, this is my positive terminal and this is my negative terminal. So this is my voltage and the current is entering into this direction. So I can write it down. My power is equal to V into I, and this is my delivering power, because the sources you will be seeing, okay, like this plus minus, and current actually flows like this. It means it will be delivering, this particular source is delivering the power. That's the reason it is positive. Understood? So let us say if I give you an example that plus 20 watt of power is absorbed, it means I will write it down minus 20 watt of power is delivered. Similar to that, let us say plus 50 watt of power is delivered. It means I will tell minus 50 watt of power is absorbed. So this is the understanding that you must have, like what is the power absorbed, negative of that will be delivered. Understood? So why don't we do one thing? I'll take a simple question and try to make you understand how it is working. So let us say a question is very simple question, that comment regarding the power of the following elements. Comment regarding the power of the following elements. So what are the elements that is there? I will quickly draw it and you have to write it by yourself. This is, let us say, positive, negative, and this is my 2 volt, and the current entering through this is 3 ampere. So this is my first one. Next one is, we have a current element like this, and the current element is 3 ampere, and this is positive, negative, and the voltage across this is 2 volt. Understood? Then we have a voltage element, and then the current entering through this is minus 3 ampere, and the voltage across this is minus 2 volt. Okay. Similar to that, we have a current element like this, coming down, and the voltage across this is positive negative minus 2 volt, and the current value of this particular thing is minus 3 ampere. Okay, so you have to tell what is the power absorbed and what is the power delivered in each of the cases. So take a moment of time and try to make the solution. All right. So can we write it down for the first one? My power is what? V into I, right? So power is nothing but V into I. So that can be written as 2 into 3, that is 6 watt. And now you tell me the power is entering from the positive terminal. You can see current is entering from positive terminal. So I can write it down 6 watt absorbing. Okay. So I can write it down 6 watt absorbing. And similar to that, it can be also written as minus of 6 watt delivering. Understood? Similar to that, come to the second one. Power is equal to 3 to the 6 again, right? Now, can you tell me, actually the current is entering from positive terminal to negative terminal. Okay. So this is again absorbing. So it will be absorbing, or minus 6 watt delivering. Next one, if I talk about what will be the power. So power is 3 to the 6 minus 2 into minus 3, that is 6. So I will write it down 6 watt. Now it is entering from negative terminal to positive. So basically it is going to deliver the power. So it will be delivering. Okay. So you don't think about this negative and this negative. You think about which terminal we are entering the current. Okay. So that will be equal to minus 6 watt of absorbing. Last one, can you tell me? 3 to the 6, again it will be power will be minus 2 into minus 3, that is 6 watt. Now you talk about whether it is absorbing or delivering. So it is entering from positive terminal, so it is absorbing. Very simple. So that can be written as minus 6 watt delivering. So this is the concept, or this is the understanding that you must have to solve any kind of question. Okay, so why don't you do one thing, take one more question. I'll just give you, this is a current source which is of let us say 2 ampere, and the voltage is there like this is my positive terminal, this is my positive terminal, this is my negative terminal, and voltage is minus 3 volt. So can you comment about the power in this? So power will be equal to V into I. So V into I is 3 into 2. So that is minus 6, right? So minus 6 watt. And you can see current is entering from negative terminal to positive terminal. It means it is delivering, right? So minus 6 watt delivering. It means it can be written as 6 watt absorbing. Okay. So you don't think about minus plus here. Minus 3 into 2 is minus 6. This is delivering. So you can write down a comment here that A is for absorbing power and D is for delivering power. So now you have understood what is absorbing power, what is delivering power, or how it is calculated. Now let us talk about what is Telegens theorem. Okay. So we will talk about Telegens theorem. In this Telegens theorem, what it says is the sum of total power in a circuit at any instant of time is always zero. The sum of power, or sum of total power, I'll write it down. Total power in a circuit at any instant of time is always zero. So what you do is you can, like make your note along with me so that you don't have to wait, or like you don't have to make again a separate note about it, because this is going to be a complete, like a complete course for your gate preparation, and there is nothing additional required for you in network theory at all. That is for sure. Okay. So what is the meaning of this statement is the sum of total power in a circuit at any instant of time is zero. It means I can say the summation of my total power Pt is equal to zero. It can also be written as the summation of all the power absorbed, ABS or A, I will just write it down, Pa is equal to zero. Absorbed power. Okay. And this is total power. Let us say similar to that the sum of all the power delivered is also equal to zero. Understood? So can we reach to a conclusion that if sum of absorbed power is zero and sum of delivered power is zero, so I can write it down, my summation of absorbed power is equal to summation of delivered power, and this is nothing but the Telegens theorem. Okay. So Telegens theorem tells, I'll write it down that comments little later. Let us say I'll put one schematic. Okay. So let us say one circuit is there. This is my plus minus, and let's say this is again one more voltage source plus minus. So this is, let's say, 8 ohm, and this is going to be, let us say, 20 volt, and this is 4 volt. So I will give you a, like a trick about about solving a circuit question. So whenever I am drawing a question circuit, that will be of one color, and if I am going to make some changes, you can make the same changes in your circuit, and you don't have to redraw the circuit. Okay, so that will be a solution circuit. Okay, so that's all. So can you quickly tell me what will be the current flowing through this? So you know already 20 minus 4, that is 16, and 16 by 8, that is 2. Understood? So 2 ampere will be flowing. So this will be my positive, this will be negative, and the current flowing through this is 2 ampere. That's all. So you already know, and the power across this 8 ohm will be 8 to just 16, that is 16 watt, or sorry, 16 volt. So this will be my 16 volt. Got it? So you can say power of each element. See, I told power of each element in the circuit at any point of time is zero, right? So can I tell it down? Let us say power of 20 volt. That will be what? V into I. So 2 ampere is the current, right? You write it down, P equal to V into I. Now power of 20 volt will be what? V into I is 2 ampere. So basically 22 is a 40. So I'll write it down 40. And whether it is delivering or absorbing, so since it is entering into negative terminal, so it means it will be delivering. So all the delivering, like energy or all the delivering power, I will write it down. So it can also be written as minus 40 watt absorbing. Okay. Now power of 4 volt, power of 2 ohm, these two also I have to calculate quickly, right? So can you tell me power of 4 volt is how much? 2 ampere is entering. Okay. So it will be absorbing power. So it means what? 4 to the 8. 8 watt is absorbing, means what? Delivering will be how much? Minus 8. This is 8 watt absorbing. Now across resistor you always write it that it will be always absorbing. Okay. It means what is the what is the power that is absorbed in this? It will be V into I. So 16 into 2, that is 32 watt. So it will be minus 32 watt delivering and 32 watt absorbing. Understood? So I have told you guys what is that? That the sum total of all the energy delivering or absorbing is equal to 0. So can you write it down? 40 minus 8 minus 32, that is going to be 0. Similar to that, what is the total amount of absorbed power? That is again 0. So this is how called as Telegens theorem. So you can tell it down that you can tell that Telegens theorem, it means it is conservation of power. Understood? So conservation of power is the principle that comes from Telegens theorem, and it tells that my summation of all the power absorbed is going to be equal to summation of all the power delivered. So this is my Telegens theorem, and it is also independent of the nature of interconnection. Okay, it is independent of the nature of interconnection. Got it? So this was all about Telegens theorem. Now let us talk about resistor. Okay. So in resistor, we'll talk about resistance. So what is resistance? So basically resistance is nothing but it is the ability, or it is the, like nature, or it is the feature of an element. Okay. So you can say the ability of a circuit element to oppose the flow of current is known as resistance. So what is the ability of an circuit element which is opposing the flow of current is nothing but called as resistance. And the element which is designed for this purpose, the element which is designed for this purpose is called as resistor, or is known as resistor. Okay. So resistor is actually represented like this. Okay, so this is my resistor, and its unit is ohm. Okay, so this is how resistor is represented. Now let us say resistor is nothing but a element. Okay, so it is made from conductor to a certain ohm. So it is nothing but an element. So let us say we are going to make a resistor like this. Okay. So what is going to happen? It is having a length which is this much. Okay. So let us say I am going to put length this much, and this is my cross section area. Okay. That's all. So based on the dimension of this element, we will be able to find out what is my resistance. So you can say the resistance of this particular element will be equal to R, and this R is nothing but is equal to rho L by A. Okay, where A is the area, cross section area of this. Okay, so A is cross section area of this one, R is the resistance of this element, and rho is the coefficient of resistivity. Coefficient of resistivity. So can you tell me that my resistance will be more when the length is more. So the length of element is higher, resistance will be higher. The area of cross section is higher, means resistance will be lower. So thicker element or thicker wire will be having low resistance, and thinner wire will be having high resistance. Okay, and the coefficient of resistivity is nothing but the nature of the element that is being used. Okay, so it depends on the material that is being used. Okay, that's all. So you can say my resistance increases when my length increases. Okay, and my resistance decreases when my area of cross section increases. Okay, so this is how it works. So why don't we take a gate question that was asked in last years, and it will be easy for us to understand through this particular question. So it is a resistance based question, but it is very good question. The question is, a resistor of value R is stretched. A resistor of value R is stretched such that its length increased by n times. Stretched such that its resistance increased by n times. The original length. The original length. Okay, then what is the new resistance value? Okay, what is the new resistance value? Okay, that's the question. So take a moment of time and try to solve it by yourself. So let's say we have an element like this, okay, whose length is, let's say, some L value. Okay, so it will be having some cross section, let us say, whose area is A, and the resistance, radius of this particular resistor of radius of this particular cross section is R. Okay, so that's the thing. Understood? So what will be the thing that will remain constant for this particular element if it is going to be stretched? So since the element is same, so its volume will remain constant, right? So can we say that what is the can we find out volume first? So volume of a cylinder you know already. What is the volume of cylinder? V is nothing but your area of cross section, that is your pi square, pi r square into h, that is nothing but height of the cylinder, that is nothing but my length. Understood? So let us say we can write it down, my volume is nothing but pi r1 square L. Okay. Now what will be the new volume? So new volume will be, let us say, pi r2 square into nl, because the length was increased to n times. Okay, that's all. So now both the volumes will be same. It means I can write it down that r1 square is equal to pi and l will get cancelled, so n r2 square. That's how we can write it down. Got it? Now you know already that my resistance is nothing but rho L by A. So we can write it down, my, let us say, R2 is equal to what? This is my, let us say, R1. So R2 will be what? Rho, and L is what? NL, right? Divided by A is what? Pi R2 square. Okay, so this is how it is there. Now can you tell me this is going to be equal to, from here we will try to find out what is my R2. Okay, so from here can we find out what is my R2 square? So R2 square is nothing but R1 square by n, right? So I can write it down here. In this case I can write it down, my R2, that is resistance of new element, will become rho NL, that is rho NL divided by pi. R2 square is nothing but R1 square by n. So that is going to give me rho L by pi R1 square into n square. And you know already rho L by pi R1 square is nothing but A, right? Rho L by A into n square. So you can say this rho L by A is your original resistance, which is R into n square. So I can write it down, n square R. So my R2 has become n square times the original resistor. Okay. So if length is stretched to n times, the resistance will be increased by n square times. Okay. What is the method 2 that you can do by yourself? Let's try out another method quickly. So let us say method 2. What was the thing that is there? Can I write it down, my original resistance, which was rho L by A, right? Now if I try to find out quickly rho L square by A into L, I can write L I multiply up and down both. So A into A, like area of cross section into length, is nothing but your volume. So I can write it down, my R is equal to rho L square by V, that is volume. Okay. So what is constant here? I can see for the given element my rho and V both are constant. So I can write it down, it is, let's say, some constant K L square. So that is my original resistance. Now what will be my new resistance? So let us say my R1 by R2 is nothing but K will remain same because it is a constant. So I will have L1 square by K L2 square. Understood? So our aim is to find out what is my R2. So from here I can find it out. My R2 is equal to, K will get cancelled. So it will become L2 square by L1 square into R1. And it is nothing but L2 was how much? N times. So I can write it down, N L1 square by L1 square into R1. So that is nothing but N square, and L1 will get cancelled. So it will become N square R1. So my R2 is nothing but N square times R1. Okay. That's all. So this was the solution for this particular question. Now let me give you a temperature dependence of resistance. Okay. Temperature dependence of resistor. So how it works is, let us say we have temperature T1 and we have temperature T2. Then the resistance at temperature T2 of an element can be written as the resistance at temperature T1 multiplied by 1 plus alpha times T2 minus T1. Okay, where I am considering T2 is greater than T1. Okay, so this is what I am considering the fact that T2 minus T1 is a positive quantity. So you can say if my alpha is positive, that is called as thermal coefficient. Alpha is thermal coefficient. So for conductors it is positive. Okay, alpha is actually positive for conductors and negative for semiconductors. That is different thing. So we'll talk about only positive. So you can say my RT2 will be greater than RT1 because resistance at temperature T2, which is higher temperature, will be greater because alpha is positive. Understood? That's all. Now let us talk about Ohm's law. Okay. Ohm's law. So Ohm's law, what it says is my current through an element is inversely proportional to voltage. Okay, so you can write it down. Sorry, it is directly proportional to voltage. So you can write it down. I is equal to 1 by R times V. Okay, voltage. So what it says is basically you can say this is the graph for resistance versus voltage versus current. Okay, so let us say this is my voltage and this is my current. So what is going to happen is it is like this. So let us say this is my origin 0 0 and the slope of this is going to be 1 by R. Okay, so you can say my voltage is nothing but I into R. Okay, and you can say my R is always greater than equal to 0 but less than infinity. Okay, and you can say my resistance is never 0 and it is never infinite. This is the true statement. Nobody can say that it can be equal to 0 or it can be equal to infinity. This is actually wrong. Okay, so you can say always R is between 0 to infinity but never equal to 0, neither equal to infinity. That's all. So let me give you different cases about it so that you can have a good understanding. When my current will be 0, what will happen? When my voltage will be 0, what will happen? Understood? So those two cases are there. So current will be 0 means it will be a straight line like this, horizontal line. Voltage will be 0 means voltage will be 0 in this vertical line. So this is how it will work. So let us see that. Let us say case 1. Case 1 tells me that we have this particular voltage current curve and my current is 0. Oh, sorry, the voltage is 0 means it is vertical line. So this was my current and this was my voltage. So you can say that this is 0 comma anything. Understood? So it means what? The voltage is 0 means it is nothing but your short circuit. Short circuit. This is SC. Okay. So you can say SC like short circuit will happen when the short circuit will happen when my slope is infinite, that is 1 by R goes to infinity. Okay. It means my R is actually nothing but 0 for short circuit. Resistance is 0. It means voltage is actually 0 and current is anything. So voltage will be 0 but current will be any value. Okay. So this is nothing but my short circuit case. And it happens like this. You can say that I is what? V by R. And you can say voltage is 0 right now here, but it may be possible like 0 by 0 form is coming, right? So that is not possible. However, you can say that's the reason that I can be anything. I am not sure what is the value of I during short circuit. Okay. It can be 10 ampere, 20 ampere, 30 ampere, 100 ampere, 500 ampere, anything. Okay. So you can say you can say that the short circuit element, let us say we have like this 100-volt source, and let us say it is having a practical source, so it will be having one internal resistance, let us say 5 ohm, and now it is going to be short circuit. Then there is no resistance at this place, so it will be short circuit. But still, even if you directly connect this wire, this particular circuit doesn't like short circuit or doesn't go in catastrophic form. Why? Because the source will be having its internal resistance, which will save the circuit for having infinite amount of current flowing through this. Okay, so that is the understanding that you should have. Let us talk about case 2. Case 2 can be what? Case 2 can be a possibility of the current is 0 but voltage can be anything. So this is the case. Okay, so this is my voltage and this is my current and this is anything, that is x-axis is anything and y-axis is 0 always. So this is nothing but your open circuit, that is OC. So OC, what are the different cases that is going to happen? My 1 by R will be nothing but 0, that is slope is 0. In that case 1 by R is 0 means what? R will be infinity. It means it is open circuit and my voltage can be anything. I will be always 0. Understood? And in that case you can have that voltage is equal to I into R and that I is 0 into infinity. So this is how, this is the case which is an indeterminate form. Okay. So let us say a simple circuit if I draw, I can have one circuit, let's say 2 ohm, and we have, let's say 100-volt source. So it can have, let us say 2 ohm here as well. And this is the one which is, let us say, open circuit, like nothing is connected here. So this is how it is going to give us an open circuit condition. Okay. So based on these two cases, you can write down a statement like what happens during short circuit and what happens during open circuit. So short circuit, current will be anything. In open circuit, voltage will be anything, current will be 0. Okay. So these two statements we can write it down quickly. So the current through short circuit, the current through short circuit and voltage across open circuit. Open circuit is always decided by, is not infinity. Okay, like current through short circuit is infinity. No. Why? Because this short circuit current will be decided by surrounding elements. Okay, the voltage across open circuit will be decided by surrounding elements. There is a possibility that this can be 2 ohm, this can be 20 ohm, this can be 200 ohm, this can be 1 ohm. So based on this particular resistor, the open circuit voltage will be decided. So that's the reason I am telling you that open circuit voltage is never, like infinity. Okay, it is decided by the surrounding element. Similar to that, short circuit current is never infinity. It is decided by the surrounding elements. Okay. So you can write it down. And voltage across open circuit is always decided by surrounding elements. But they can afford any value. Okay. However, they can have any value. It is not known like what value they can have. They can have any values. Okay. Now let us talk about power and energy of a resistor, because this is going to be very important topic. Okay. So I am going to write down power and energy of resistor. This is you already know, okay? So what is that? Let us say we have a resistor element and the current flowing through this is, let's say, I. The voltage across this particular resistive element is V. So in that case, you know already V is nothing but I into R, and I can write it down, my power P is equal to V into I, which can also be I square into R, which can also be V square by R. And similar to that, we actually generally, like put it in the form of root mean square value. Okay, so that is nothing but IRMS. So IRMS square into R, or it is nothing but VRMS square divided by R. Okay, the energy, let us say we represent it by E, is going to be PDT. So PDT, which we have studied in first session, so that will be T1 to T2. Let us say time T1 to T2 power integrated across the time. Okay, this can also be written as integration of T1 to T2. Power is nothing but what? Instantaneous power, I can write it down, which is going to be I square R. So I square of time into R dt. Okay. And this can be written as I square into R multiplied by T2 minus T1 for DC current. Okay. So for DC sources, we will have I square into R multiplied by time difference. And for AC or instantaneous or varying current source, we can see that integration of I square T into R dt. Okay. So let us take a simple question. The question is, the current passing through a 5 ohm resistor is, the current passing through a 5 ohm resistor is I of t, which is given as e to the power minus 2t u of t, where u of t is unit step function. Calculate the energy dissipated. Calculate the energy dissipated. So it means if time is not given, what is the time, what will be the energy? It means you have to calculate it for complete time zone. Okay. So complete time interval you have to calculate. So it means what? Can you guys take a moment of time and solve it? Let us see. The energy E is equal to integration of, what is that? P into dt, right? So P dt, let's say T1 to T2. So T1 to T2 we have to put it complete time interval. So it is nothing but integration. Since this is u of t, so I can write it down 0 to infinity. So I can write it down 0 to infinity. And P is nothing but what? P is equal to I square T into R, right? So you know already I square T into R dt. So that is going to be equal to integration of 0 to infinity. I is how much it is? E to the power minus 2t. U of t is cancelled because it is 0 to infinity I have already taken, into 5 dt. So quickly do it. 5 into e to the power minus 2t divided by minus 2 from 0 to infinity. So if you calculate that, you are going to get my energy is equal to 5 by minus 2 I will take out, and it is going to be e to the power minus 2t. So minus infinity, that will become 0, minus e to the power minus 0, e to the power minus 2 times 0, that is 1. So this is going to be minus minus plus. So it is going to be 2.5 joule. Okay. Oh, sorry. This is going to be how much? I square. Okay. So basically it will happen I square. It means I was e to the power minus 2t. So I square will be e to the power minus 4t. Okay. So this will be 4t by it will be 4. So this will be 4. It means it is nothing but 5 by 4 is nothing but how much? 1.25 joule. Got it? So all right. We can keep up to this and then we'll try to solve more questions in our upcoming sessions. Thank you.